All right. Um, let's look at some examples of some popular questions on Math Excel, talking about the periodic characteristics of these trigonometric functions, right? So for the sine of pi over 3, again, at this point, I mean, we should know whereabouts pi over 3 is. It's right around there, right? Now, if we subtract 15 pi from the angle, right? Think about coterminal angles. Think about the work that we did where we said if you add or subtract 2 pi to any angle theta, you're going to end up in the same spot, right? Now that applies to any, because the period of the sine wave and cosine wave is 2 pi, that applies to any multiple of 2 pi. That's why we always put that n after it, okay? So for example, here's pi over 3, right? This is the angle for pi over 3. That's 60-degree angle. It terminates in quadrant 1 in this position. If I add 2 pi to pi over 3, okay, all that does is it takes the quote-unquote arm of this angle and it swings it around one full rotation, and it ends up there, okay? If I do that twice, and I don't want to get too granular with this, but we might as well. If I take any angle and I add 2 pi, right? And then I add 2 pi again, this is just 2 rotations, right? 2 rotations around the unit circle. Well, that's the same as theta plus or minus 4 pi, okay? So adding moves the arm of the angle or rotates the arm of the angle clockwise. Well, if I subtract, it's kind of the same idea, right? Only we're going in the opposite order. But if I subtract by what amounts to be in this problem an odd multiple of pi, that doesn't take me one full rotation around the unit circle. Here's a different way to think about it. This would be the same as pi over 3 minus 14 pi. Here's our even multiple of pi, or a full rotation, and getting that coterminal angle, and then subtracting pi again. So I'm not trying to put you in a trance here, but if I was at pi over 3 and I subtracted 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14 pi, it'd be here. Then if I subtracted another pi, what's pi? Pi is 180 degrees, so that's only half of a rotation, which puts us down here, right? It's still on this diameter, right? It's still a pi over 3 angle, but now it's down here in quadrant 2. So whereas before the sine of pi over 3 was radical 3 over 2, because that's the y coordinate up here, radical 3 over 2, right? Down here, we have the same y coordinate, but it's negative, right? So the sine of pi over 3 minus 15 pi, which is this, which puts us down here, is negative radical 3 over 2, right? We're trying to find that other angle.